Welcome to our guide, The Art and Science of Prompt Engineering. In this course, we'll explore how carefully crafted prompts unlock the real potential of AI, turning tools into reliable collaborators. By the end, you'll have practical techniques and a clearer mindset for using prompts effectively in both academic and professional settings. When we ask what prompt engineering is, think of it as the craft of writing inputs that get the right outputs from AI. It's the bridge between human intent and machine understanding, and it directly shapes how useful, relevant, and accurate AI responses become in real tasks. Prompt engineering matters because it improves AI output quality, helps the model focus on what you actually need, and speeds up workflows by reducing trial and error. These benefits cut across industries from education to healthcare, meaning better results with fewer iterations and clearer, more precise answers. Looking back at AI's evolution helps us understand why prompts are so powerful today. Early systems required rigid commands. Then NLP added basic understanding, and now advanced LLMs grasp nuanced language. The future points toward multimodal prompts that mix text, images, and audio, broadening what prompts can achieve. The real-world applications are wide-ranging. Customer service chatbots that resolve issues with carefully designed prompts, content creation systems that draft marketing and creative copy, and data analysis assistants that transform complex datasets into clear insights through targeted prompting strategies. This slide contrasts a vague prompt with an improved one to show how specificity changes outcomes. A broad request yields generic information, while a focused prompt, citing a specific report, region, or goal, produces targeted, actionable insights that are actually useful for decision-making. Key challenges in prompt engineering include ambiguity when user intent is unclear, managing and mitigating model biases, and optimizing length and structure, so prompts provide enough context without overwhelming the model. Addressing these helps produce more accurate and fair outputs. At a basic level, AI models are trained on vast text datasets, then process prompts by analyzing patterns and relationships, and finally, generate responses by predicting probable next tokens. The quality of outputs relies on both the underlying model capabilities and how well the prompt guides it. Here are a few essential terms to know. Tokens are word fragments the model processes. Temperature controls randomness and creativity. Fine-tuning adapts a model to specific tasks. And the context window is how much previous text the model can remember during a conversation. This section wrap-up reminds us of the big picture. Prompt engineering is the strategic crafting of inputs to guide AI outputs. Real-world applications demonstrate practical value, and a basic technical foundation shows how models interpret prompts. Next, we'll dive into prompt design fundamentals. Designing prompts starts with careful crafting of language for clear AI interpretation, followed by refining to remove ambiguity, testing through feedback loops, and finally mastering techniques so you can consistently get desired outcomes across use cases and iterations. A good prompt balances clarity, specificity, relevance, and scope so the model understands exactly what you want without being overloaded. Clear language avoids misinterpretation. Relevance keeps the model on task, and balance provides enough context without drowning the model in unnecessary detail. Prompt structure can take many forms depending on goals. Open-ended prompts encourage creativity. Closed-ended prompts seek concise answers. Multi-turn prompts build on earlier exchanges. And instructional prompts give step-by-step guidance for complex tasks to help the model follow a precise workflow. When crafting clear prompts, avoid vague requests, conflicting instructions, and unnecessary jargon, and instead use precise language, single-purpose requests, explicit formatting guidelines, and clear context statements so the model can focus on the one task you want it to solve. Using context in prompts means providing background information, specifying the intended audience, and clarifying the purpose so the AI tailors its response appropriately. For example, Mention source material, or say who the explanation should be aimed at to get more relevant and usable outputs. Effective contextual prompts include concise background facts, clear audience specification, and a purpose statement that explains why you need the information. These elements help the AI interpret the situation and produce responses that match both content needs and the intended recipient's level of understanding. Tone matters. Specifying a desired tone like formal, conversational, or persuasive increases response, relevance, and engagement. And research shows audience engagement often improves when content matches expectations. Calling out tone up front helps the model maintain style consistency across the output. Adding constraints sharpens results by limiting length, specifying style guides, applying content filters, or defining the target audience. Commands like asking for a 100-word summary or explaining a concept to a 10-year-old give the model clear boundaries and produce outputs you can use immediately. Refining prompts iteratively is a practical process. Start with an initial draft. Analyze the AI's response to find gaps. Adjust the prompt by adding context or constraints, then test again. Repeating this cycle leads to steadily better, more reliable outputs over time. Common pitfalls include overloading the prompt with too many instructions, assuming the AI already knows niche or up-to-date facts, ignoring how tasks scale for longer responses, and oversharing sensitive information that raises privacy concerns. Avoiding these improves reliability and safety. Using examples, or few-shot prompting, helps the model learn the pattern you want by demonstration. Including 2 or 3 well-chosen examples dramatically improves performance on complex tasks, because the AI can generalize the structure from those examples to new inputs. Chain-of-thought prompting shows why asking the model to reason, step by step, produces more transparent and often more accurate answers. A standard prompt may return a short result, while asking the model to think through each step yields the intermediate reasoning and a clearer final answer. When testing and validating prompts, measure performance across baseline, refined, and optimized versions to track improvements. Visualized results often show steady gains in relevance and correctness as prompts are tightened, and validation should include both automated metrics and human review. Prompts work best for tasks like classification, transformation, creation, and interaction. Examples include sentiment analysis and topic identification, summarization and translation, story generation and idea development, and Q&A systems or tutorial assistants that require conversational handling. This section wrap-up reminds us that structure, refinement, and testing are the core practices for building prompts that reliably produce desired outcomes, and that using systematic approaches speeds adoption and improves reuse across different projects. Advanced techniques include parameter control to fine-tune response characteristics, multi-stage prompting to break complex tasks into smaller steps, and system integration to combine AI with external data sources and workflows for richer, more accurate outputs. Temperature and other sampling choices shape creativity versus predictability. Lower temperature yields more deterministic outputs, while higher temperature increases variety. Sampling graphs often show how response diversity changes with settings, and choosing values depends on whether you want novelty or consistency. Top K sampling restricts token selection to the K most probable options to increase predictability, while Top P sampling dynamically chooses tokens, covering a cumulative probability mass to balance creativity and coherence. Both techniques let you tune how adventurous the model's output should be. Modal control means prompting the model to operate in different modes. Analytical mode emphasizes step-by-step reasoning and evidence. Creative mode favors novel combinations and metaphors. And instructional mode focuses on clear objectives and sequential steps for task completion. Advanced chain-of-thought reasoning breaks a complex problem into an initial problem statement, decomposition into sub-questions, sequential logical steps to solve each part, and finally, integration of sub-solutions into a coherent overall answer, improving reliability on multi-step tasks. Multi-turn conversations lean on conversation memory, so the AI retains context from earlier exchanges. Use progressive refinement where each turn narrows focus, and apply context management to preserve key details while integrating new inputs for a coherent dialogue. API-based prompt specifications show how prompts are structured in programmatic calls, typically including system and user messages along with parameters, like temperature and max tokens. This makes prompt behavior reproducible and part of automated pipelines for production use. Combining external data sources enhances AI outputs by retrieving current information, processing and cleaning it for AI consumption, integrating insights with original data, and using prompts to analyze and interpret that external data for actionable outputs. Evaluating and adjusting bias involves identifying primary bias types like selection, representation, and algorithmic issues, applying refinement techniques to reduce bias, and validating with multiple sources because diverse validation approaches often double improvement in fairness metrics. Experimenting with edge cases tests prompts against extreme or unusual inputs to reveal hidden assumptions and limitations. This exploration helps identify breaking points and build more robust systems by adjusting prompts or adding safeguards where failures surface. When prompting multilingual models, always specify the language you want and consider cultural context, dialects, and appropriate honorifics. Clear language specification and cultural notes help produce accurate, respectful translations or localized outputs for diverse audiences. Real-life examples show how students use guided prompts for academic assistance. Marketing teams employ specialized prompts for consistent brand voice, and developers adopt prompt templates to automate documentation and testing. These use cases highlight prompts' tangible benefits in daily workflows. Designing prompts for creative tasks involves clearly specifying the subject, defining stylistic references, adding technical parameters like medium or lighting, and describing the intended emotional resonance so the AI can generate outputs that match the artistic vision you have in mind. When errors or miscommunications occur, identify where the response diverged from expectations. Analyze whether ambiguity, complexity, or gaps cause the issue. Reformulate the prompt with clearer instructions or context, and validate the new prompt to make sure the original problem is resolved. This section wrap-up emphasizes 3 practical pillars: expert mastery of advanced techniques, technical control through parameter adjustments and integrations, and system-level implementation to connect AI with other tools and data sources for real-world applications. Looking forward, Practice and Ethics Guide: How Prompt Engineering Evolves. Today we build skills and best practices. The near future brings standardization and broader adoption, and the long term will see integration with emerging technologies and new paradigms for human-AI collaboration. Ethical considerations focus on fairness to avoid reinforcing biases, safety to prevent harmful or misleading content, transparency about AI involvement in content creation, and inclusion to design prompts accessible to diverse users and perspectives for more equitable outcomes. Optimizing prompts starts with establishing clear goals and measurable success criteria, implementing systematic frameworks for different prompt types to ensure consistency and reuse, and continuously analyzing and refining prompts by testing against benchmarks and incorporating user feedback into improvements.